in German. Good morning, everyone. I'm Xingyu. Now I'm the postdoc research fellow in the Hong Kong University of Science Technology and under the supervision of Professor Jack Chen. And very happy to attend this workshop. And my presentation title is Blockchain as a BIM Service, Secure and Decentralized Common Data Environment for BIM Design Collaboration. So now we're in a time or era of construction digitalization, like using various digital technologies. However, the increasing of these digital technologies will inevitably raise the cybersecurity concern. So here are some cybersecurity risks reported in the construction industry. For example, the construction industry was the third target of ransomware attacks in North America. And there is real cases that the database of a construction company has been hacked and a lot of important data has lost. And attacks on the AEC companies constitute 28% of all attacks. Therefore, the latest ISO standards has suggested the security mandate approach should be developed as early as possible in the planning stages. So in terms of BIM, or more specifically of my topic, BIM collaborative design, a lot of BIM platforms or CDE platforms relies on centralized database. That means all the BIM data placed in one database. This centralization will raise the problem of data manipulation, like the hackers can change or delete the data, resulting in no traceability and no integrity. And if you rely all the data on one administrator or one third-party vendor, so single point failure problem will result in access rejection or loss of data. So we know that blockchain provide decentralized or distributed data storage, and all the data in the blockchain is unchangeable, traceable, and stable. So blockchain shows potential to solve the mentioned cybersecurity risks. So the IEC report has suggested that blockchain is naturally fit for secure BIM collaboration. So this research or this topic is going to share a blockchain as a BIM service with three parts. The first part, we will consider how to decentralize the BIM data in a decentralized CDE framework. And then based on that, how to make the compliance checking or data security more compliant with the existing standards. And after that, we will develop a BABS prototype for BIM collaboration. For the first work, we know that blockchain cannot store larger size BIM data like in GB or TB level, and it only allows for data transactions. So we choose the IPFS. I know most audience here are very familiar with this decentralized technology that we can share large BIM data in and get the CID or hash value of the file content and use the CID to access the corresponding data. And in this way, we can share large data in CID and only place the metadata, including the CID, in blockchain to decentralize the BIM data. Here is the centralized common data environment framework. So this framework is decentralized and very different from existing CDE. First, they have the same work in progress using local software, but they have a different centralized shared container or shared state. Original BIM files are placed in IPFS and the CID and other data in blockchain. And when you deliver this data to a downstream teams to publish, or they may have another IPFS and other blockchain to separate the data to protect the data privacy, and also they will have a different decentralized archive. In this decentralized CDE or DCDE, we still develop two technical elements. First is the transaction data model defines what information should be shared in a decentralized network. So there are two examples of the data models. They have key-value data model to be compatible with the blockchain requirements, and all the metadata are designed based on ISO standards, so it will have a better interoperability across different CDE platforms. Also, it contains CID that all the data are verifiable, and finally, it provides completed data, including the issues, together with the dependent models. Here, the smart contract algorithm, actually, Professor Jackson introduced briefly previous. So in this smart contract algorithm, we do not push the data directly to the blockchain. Instead, we have some endorsing verification process to ensure that the shared BIM data in right format and are all proposed by authorized user. So another challenge of the collaboration blockchain is we found, yeah, smart contract can share data in blockchain. They cannot check the correctness or compliance of this data in the metadata in the transaction. So actually, the smart contract is not smart enough. Actually, for our sixth element, the second element in this BABS architecture is smarter smart contract algorithm. So to develop such smarter smart contract algorithm, we will solve the two technical challenges. First is the complex checking rules. And yeah, we need to define what rules should be integrated in blockchain or in smart contract to make the smart contract more smart contract. And after that, with these the rules, how to make the how to integrate into a existing smart contract algorithm to make it can check the correct or wrong of the input data. So the algorithm, the rules are established based on ISO standards, which provided a comprehensive and completed information about metadata regulation in BIM collaboration. And finally, we selected 270 knowledge triples, and we categorized them into 4 groups, including the information sharing metadata and the ownership data, collaboration metadata, or data security metadata. And with these triples, we categorize them into these categories, and then we build an ontology on them. Why we build this ontology? Actually, some rules can directly get from the standards, but some rules we need to do some reasoning. And this is one of the very first work that has built such ontology on top of the ISO 19650 standard series. So we're going to reason this rule. So we develop SWRL reasoning algorithms to reason what the metadata complex checking rules are embedded in the ISO standards. So here are our algorithms, and there is the results, and we get 29 direct rules, which we can direct from the text, and 12 reasoned rules. So within these rules, we're going to integrate them to into the smart contract structure to make the smart contract more smarter. So here, the first step, we assign or mapping these rules to different transaction data models. So this transaction is used for sharing the BIM model metadata. This is for issue management, and this is for model delivery. So each items actually has corresponding rules to check. So later we can, in the smart contract, we can check what item using what rules. So this is the mapping process. And then we develop the information. We develop the smart contract algorithm. This algorithm has a new architecture, not only the transaction validation and the transaction interaction, but also we have a complex checking item here. Now within this engine or within this part, they state if the each items of this transaction will be checked to ensure the data quality that's shared in blockchain. So finally, we develop a BS prototype for BIM collaboration. So this is the user interface of our prototype. Yeah, Professor has mentioned already. So there are 3 main functions: so model and version management, and the design issue management, and blockchain records. Besides this main phase, and we have some other pages like list of design files and version control, and the fast blockchain registration kit. Here, the example of how can we collaborate, or whether we can do the design collaboration in such a prototype. So here, example that we can share a BIM model in the IPFS, and this IPFS has different users or IP addresses. And the result shows we can get the CID, the hash value, and then we use the hash value to share it in blockchain and use this CID to in blockchain to get the original BIM data. So we can successfully decentralize BIM data in our prototype. And also we can perform the design coordination, like we can propose design issues in DCDE, and we can coordinate on these issues in this DCDE. And for the smarter smart contract part, here are some examples, like if this transaction actually has the wrong, the version and the status code is not matched. This status code is used for work in progress, but now I'm going to share this new data. So our smarter smart contract can check that the status name does not match the version format, and the status name does not match the status code. So this transaction will be rejected, and you need to revise it and re-upload it by revoking the smart contract to broadcast in your collaboration network. And also, if you miss some items, columns, like if you propose a design issue, but you ignore the consultant people, and our smart contract can detect. So the consultant should not be empty, and you need to revise it. And in the delivery phase, if you deliver something that is sensitive, some model sensitive, but you missed that, and you share these deliveries to all people, and our smart contract can detect the strategy contains sensitive information, and thus the reviewer should not be empty. The receiver should not be all, or should be empty. We also did some computing testing of our proposed smart contract and our prototype, and the results shows all the latency in the millisecond level that very fast and can be accepted in the contract construction context. And we found here is this orange one is the smart contract proposed in the very first work, but the rest of three are smarter smart contract. So the smarter smart contract has a higher latency. That means spend more time in sharing data. That because we know it will have extra time for the compliance checking and do the reasoning checking extra, but the overall performance is acceptable in millisecond level. We also apply our prototype in a project, the mobile cabin hospital in Hong Kong for COVID-19 treatment and isolation. So this kind of hospital project has a BIM-based design and has a very complex process and has a very tight schedule that leads we hypothesize that this blockchain can help. And the results shows, as Professor mentioned, we can save time, 20% in some design coordination cases, and in overall delivery, we can save even to 66. Also, we received some positive feedbacks from the project members. They found our prototype is easy to operate like other BIM platforms and satisfy all the requirements, and the design logs are very easy to track, and the smart contract can securely execute the permission process. So here's the overall architectural developed elements of our BABS prototype, and later we will incorporate with other technical elements, like how to decentralize the construction AI in blockchain, and how to integrate with digital twin to has a high performance to receive all the IoT data extra or accept some open BIM standards data in our blockchain. So this work conducted by our Hong Kong USD BIM lab, led by Professor Jack Chen, and you are very welcome to collaborate with us. And here are some publications on blockchain construction, so you are also very welcome to check them. And finally, this is the end of my presentation, and my name is Turbish Tao, and thanks for your listening.